Welcome to the case study. A quick note before we jump in. This video is heavily focused on system design. There is no definite final solution at the end of this video. Instead, I want to show you exactly how system architecture is properly done in the real world. The current site was built to demonstrate how powerful agentic coding is at rapidly building, deploying, and troubleshooting web applications. It served that purpose perfectly. But now, we want to take it to the next level. A fully functional, secure, high-performance platform. And that starts with getting the architecture right. By the end, you will see how we systematically challenge different functional and non-functional requirements to prevent costly rewrites. Expect us to do some quick proof-of-concept builds along the way to validate these ideas before committing to a framework. If you look at the current live site, you can see the architecture starting to fracture. Fetching YouTube playlists dynamically oftentimes out, leaving us with a stale, hard-coded video list. And if we try to use the search button to filter content, it is completely broken. Before scaling up and adding features, I had to drastically rethink this foundation. After finding all those bugs in the live demo, I set out to rebuild the site. But before writing a line of code, I mapped out my strict architectural requirements. First, the functional requirements. I needed to fix the broken YouTube fetching natively on the server to bypass CORS limits. I also needed to fix the broken search function since it couldn't query the hard-coded lists. Finally, a markdown engine for tech blogs and setting the groundwork for a future user authentication system. Second, the non-functional requirements. This is where it gets hard. The system must be blazingly fast, highly visible to SEO crawlers, and cost exactly $0 in server fees. The entire infrastructure had to deploy natively to the Cloudflare edge. I fed this exact specification list into the AI to see what it would recommend. The AI initially suggested hitting the YouTube API directly on every request. I immediately pushed back because of their strict rate limits. Instead, I suggested we pull the data securely on the server with incremental static regeneration and cache it directly into Cloudflare KV storage. Phase 2. Avoid stateful architectures. For the future user comments and profiles, we will implement a brand new serverless database natively in Cloudflare D1. Phase 3. Use the newest version of auth.js for future edge-compatible logins. On paper, this architecture is exactly what I want. Because there is always a strict rate limit on external APIs like YouTube, I figured we needed to cache the playlist locally, in this case using Cloudflare KV. And I actually love next.js and how it behaves on Cloudflare. However, you do have to be mindful. Cloudflare relies on the V8 isolate engine, known as the Edge runtime, not standard Node.js. You have to ensure you are using the right Next.on-Pages adapter to seamlessly bridge them together. While that integration works beautifully for my current site, I was curious. Before I locked in my decision to use Next.js, if there were newer, lighter alternatives that were natively built to run on Cloudflare without any adapters at all. So I pushed back on the AI, demanding a solution that mirrors the developer experience of Next.js but compiles flawlessly to Cloudflare workers by default. The AI introduced me to one of the most controversial projects of the year, Vnext. Vnext is not a fork of Next.js. It is a Vite plugin that completely re-implements the public Next.js API surface to run natively on Cloudflare. The backstory is legendary. An engineering manager built Vnext from scratch in roughly 1 week using Claude Opus, costing around $1,100 in AI tokens. It was entirely vibe-coded to aggressively pass Next.js open-source unit tests. And the numbers were staggering. It compiled 4 times faster and shrank client JavaScript bundles by over 50%. It honestly sounded like the Holy Grail. An AI-generated competitor that beats the original framework at its own game. But as an architect, you have to look past the benchmark hype and look at the security audits. Because Vnext was synthesized by an LLM strictly to pass functional unit tests, it completely failed to understand complex runtime edge cases. Security researchers discovered massive state pollution flaws. If 2 users requested a page simultaneously, the caching layer could accidentally leak one user's session token into the other user's browser. For a simple blog, maybe it's fine, but because authentication is an absolute requirement on my roadmap, deploying to a framework with known session leaks is a catastrophic risk. The Next had to be disqualified. At this point, the complexity was spiraling out of control. So I asked the AI to go back to basics. What if we just use pure React paired with Vite? Break away from complex frameworks entirely. It is universally loved, blazing fast, and essentially the industry standard. Why overcomplicate it? The AI immediately flagged severe architectural faults for a content-heavy website. Pure Vite generates what is known as a single-page application, or SPA. Because it runs 100% in the browser, you effectively have no back-end security boundary. First, to fetch your YouTube playlist without a server, you would be forced to embed your private YouTube API keys directly into the client-side JavaScript, exposing your quotas to malicious hijacking. Second, the application payload literally loads as a blank HTML file. The user's device has to download and execute all of the JavaScript before painting the screen. Search engine crawlers struggle with this. Your new technical blogs would be practically invisible to Google SEO. The single-page application trap makes Pure Vite completely unviable for a content hub. We need a hybrid model, a framework that bundles code as fast as Vite, but renders HTML on the server like next.js, and is fundamentally built from day one to deploy to Cloudflare's edge. Since pushing next.js forces friction against the edge, and Next introduced hidden state pollution vulnerabilities, I realized we needed to step back and look at the broader 2026 landscape. First up, Remix and SvelteKit. Remix recently merged with React Router 7 and boasts a lightning-fast time to first byte, making it the mutation king. SvelteKit 2 is equally phenomenal, shipping up to 40% smaller JavaScript bundles than React. Both are developer darlings, but they might be overkill for a static blog. Then there is Hano. Hano is an absolute edge demon, operating with 0 to 5 millisecond cold starts right on Cloudflare. It is a masterpiece for APIs, but I didn't want to build an entirely new Markdown parsing engine from absolute scratch just to write blog posts. Finally, we evaluated Astro 6. Astro ships with 0 kilobytes of JavaScript by default using the Islands architecture. More importantly, it features native MDX content collections and was recently acquired by Cloudflare, ensuring it runs seamlessly on their Workers Edge runtime. To finalize the decision, I evaluated all 6 frameworks side by side against my 5 strict functional and non-functional requirements. You can pause the video here to see the final breakdown. In the end, only Astro successfully satisfied every single constraint without requiring massive custom workarounds. Now that we have narrowed down our candidates and checked them against every requirement, the next step is validation. We will need to build quick proofs of concept to stress test the top contenders. And beyond the framework itself, we still need to tackle data modeling, capacity planning, observability, disaster recovery, and CI/CD pipelines. These are the challenges that come next when taking any project from prototype to production.